Welcome to the session on Hyperview Radio's interface. This session includes a basic post-process steps to be followed for quasi-static and impact analysis. These are the steps to be followed. First, you have to check the 001.out file. In that, you have to look for mass and energy error. Mass error allowed is 2 to 5% and energy error allowed is minus 10%. And next step is you have to look for the animation file. And third one is you have to look for 5 global curves in terms of hypergraph, that is kinetic energy, internal energy, total, contact and hourglass energy graphs. And also you can plot the contact force graph, spring force graph and rigid body graph. And also the fourth step is contour results. This EPSP, von Mises hourglass, displacement, velocity and acceleration, these are the basic output requests. And this list is tells you can request all these entities in as a contour result in anim element, and this list is for can request these many requests in anim VCT. For the ease of understanding all these four steps, I've taken a simple quasi-static example. I'll just briefly go through this problem statement of this example. That is, this beam is held by a base plate and this base plate is going to fix in all degrees of freedom with the help of an R body. That is, a master node of a R body is going to fix in all degrees of freedom. And this base plate, L angle plate and beam are welded with the help of spring 13 element. And also this beam is imposed with an imposed displacement in x-axis with 300 mm magnitude, and following this unit system, that is mass in ton, time in second, length in mm and force in newton. I'll start following these four steps for this example. That is, I already have a results for this model. I'll first check the 001.out file. In that, I will look for mass and energy. I'll just open 001.out file. This error represents the energy error and this mass error. As you can see, both are within a limit. And we'll go to the next step, that is animation with the help of a hyperview. To see the animation, you have to load A0015. Say apply. For the ease of understanding, I'll plot the displacement for this. I'll start the animation. And also you can control this animation with animation control. You can set your start and end time. And this model is behaving as per the load case. I'll just stop this and we'll go to the next step. That is, I have to look for this kinetic, internal and total, all these 5 curves. To plot all these 5 curves, you have to open T01 file in hypergraph. I'll just add one more page here and I'll change it to as I said, you have to load the T01 file. In that you have to look for global variables, that is internal energy, kinetic energy, contact, hourglass and total energy. And I will select the magnitude. Before plotting this graph, you have a basic idea how your graph should follow. That is, for any impact case, this internal energy and kinetic energy graph should follow this pattern, and for quasi-static it should follow this pattern for internal and kinetic energy. For numerical energy, that is for a hourglass and contact, it should be flat to zero. I'll just review. This is how, as you can see, this for quasi-static, it's following the same pattern. And next step is, and you can also plot the curves based on part, material, property, that is shell, solid, section, whatever the kind of property you have, and spring elements. For example, if you want for a spring, especially for a 13 spring, if you want to plot a tensile forces, you have to plot force X. Since it follows the local coordinate system, you can just say preview. You can plot. This is a spring element number. You can plot force X, movement, elongation, rotation, and total energy of all or resultant of all those four categories. And also you can plot the contact forces in terms of graph. For contact, you can plot normal forces, tangential force, and total forces, and resultant for the same. And for rigid, since I have only one rigid, that is the impactor, you can plot force, movement, rotation, resultant for all the force, movement, and rotation. These entities like the spring, rigid body, contact only comes when before running the model you have to request these all entities in terms of output block. Then only all will appear here, otherwise no. And next step is, when everything is fine, you have to look for the contour results. This is the last step. In that, I requested EPSP, one masses and hourglass, and displacement, velocity and acceleration. I'll just go to the previous plane. You can plot displacement as I already showed, acceleration, just say one message. You can select either by elements or components. I'll change for averaging method to simple. Say apply. This is a one message distribution. You can change this legend by going edit legend. You can either go by fixed or dynamic scale. Also you can control your upper and lower limit, and also the results value how you want, like engineering, fixed, and also you can control the decimal over here. And also you can study by taking the section of it. Just go to section here, select any base point, and select the plane you want to cut and say apply. And also you can add one more plane by clicking add, result, say apply. You can control this section length by dragging or dragging out. By this I am concluding the session. Thank you.